Hello everyone and welcome to the video lesson for Tuesday, January 19th and Wednesday, January 20th. So classes started a little bit differently for my A classes and my B classes, since my B classes had a full day and my A classes had a half day. So if you were in my B classes, we did have a warm-up, but don't worry, it's for 0 points. We just talked about our favorite rocks, igneous, sedimentary, or metamorphic. But my A classes did not have that, so no worries, even more so for you. But both classes went into our next Google Slides document where we worked on the Solubility Gizmo. If you go to our 10th week of Quarter 2 module, scroll on down to Student Copy of Unit 5 Notes, Solubility, Temp, and Water Cycle. Clicking on that link is going to generate a copy of our notes into your Google Drive. If you've already started working on your Solubility and Temperature Gizmo as a Google document, you can just copy those answers and paste them into this Google Slides document. And then I also have a link to the Gizmo website here. This is also very important. Remember, you need to log in with your account in order to access the gizmos. This is actually a pretty long Google Slides document. If we go to our second page, you can see that I've embedded a table of contents here for you. So that way, while you're taking our next checkpoint, which will be on solubility and temperature, the water cycle, and weathering, you can easily jump around to the page that you need. But we started with the warm-up from the Solubility Gizmo. Now remember, this is what I asked you to do for homework over the weekend, so you'd be ready with your answers. If we stir a spoonful of sugar into hot water, it dissolves. One way we can tell that there is in fact sugar there, even if we can't see it, is we can taste it. And if does sugar dissolve more easily in hot water or cold water, that's great from our notes from Friday. It's going to dissolve a lot more easily in hot water rather than cold water. So next we started to warm up with the solubility gizmo itself. A solution generally consists of two parts, a solute that is dissolved and a solvent that the solute is dissolved into. For example, sugar is a solute that is dissolved into the solvent water. In the Solubility and Temperature Gizmo, we studied how temperature affects how much solute will dissolve in a solution. To begin, we checked that potassium nitrate was selected and the temperature of the water was 20 degrees Celsius. So in the solution, our solute was the potassium nitrate, which I wrote with its chemical symbol, KNO3, and the solvent was water. Remember, our solvent is almost always going to be water. When we added 10 grams to the mixture, all of it dissolved. We can tell that it all dissolved because it all disappeared and none of it was present at the bottom of the beaker. So we clicked the reset, made sure the temperature was still 20 degrees and that it was still potassium nitrate. And then we selected the bar chart and turned on showing numerical value. So we added 20 grams of potassium nitrate. Did all of it dissolve? Yes, it did. Next, we calculated the concentration. One way to find the calculation is to divide the mass of the solute by the volume of the solvent. So the units of concentration we were given here were grams per 100 milliliters. So you can write that as G divided by 100 ml, or as grams per deciliter as G divided by DL. So what's the concentration of this solution? Well, all 20 grams dissolved. And if we look at the beaker, it does say 100 milliliters of water. So we simply write it as 20 grams divided by 100 milliliters, or as 20 grams per deciliter. Now, it wanted us to add another 20 grams. Did all of the solute dissolve? No. There was some undissolved at the bottom and on the graph. So both of those things told us that not everything had dissolved. So now we wanted to figure out how much did dissolve. So we take the total, which is 40 grams, that was in the beaker, minus what did not dissolve, and that showed us that a total of 30.65 grams was dissolved in our solution. So the maximum amount of potassium nitrate that I can dissolve at 20 degrees of water and 100 milliliters is 30.65 grams. So this is its solubility at that temperature. So to write its concentration, we would simply write 30.65 grams per 100 milliliters. Now we need to reset the gizmo, keep it at 20 degrees, but change it from potassium nitrate to sodium chloride. And now we're going to add sodium chloride until it starts piling up at the bottom of the beaker. So I added a total of 40 grams of sodium chloride. Once I saw that it started to pile up, I stopped. It's okay if you added more. It won't affect your final outcome. But since I stopped at 40 grams, I had a total of 3.34 grams of sodium chloride piled up at the bottom of my beaker. So I took 40 grams minus the 3.34 that did not dissolve. And regardless of what you put in, we still should have the same final answer of 36.66 grams. So the solubility of my sodium chloride in 20 degrees water would be 36.66 grams for every 100 milliliters of water. Now the next question says at 20 degrees, how much sodium chloride could be dissolved in 2 liters of water? So there's two things we need to figure out here. First, I need to figure out how many times 100 milliliters goes into 2 liters. So 1 liter is equal to 1,000 milliliters. So I'm looking at how much I can dissolve in 2,000 milliliters of water. So I want to know how many times does this go into 2,000 milliliters? Well, 2,000 milliliters divided by 100 means I'm going to do this 20 times. So there's 20 100 milliliters in 2 liters. So if I'm multiplying this by making it 20 times larger, that means I can dissolve 20 times as much. So I'm going to take my solubility at that temperature, 36.66 grams, and multiply it by 20. So the total amount of sodium chloride that I can dissolve in 2 liters of water at 20 degrees Celsius is 733.2 grams. Then we were asked to do the same thing, but for potassium nitrate. Now, once again, it's still at 20 degrees Celsius. That has not changed. And we're scaling this up to 2 liters. So again, I can fit 20 of that one beaker into 2 liters. So I'm going to take that 30.65 grams, multiply it by 20, and I get 613 grams can be dissolved into 2 liters of water at 20 degrees Celsius. So for activity B, we reset everything again. We start the temperature at 10 degrees Celsius and potassium nitrate. And then it asks us to predict, based on our own experience, how would you expect temperature to affect solubility? So I gave you the sentence starter. If I make my solvent hotter, I can dissolve more or less solute. Well, this comes into play with our notes from Friday. When you heat things up, you should be able to dissolve more, and you should be able to dissolve it more quickly as well. So in step 2, we're now going to be gathering data so we can build our own solubility curve. First, we need to fill out our data table. So I'm going to set my simulation to 10 degrees Celsius and potassium nitrate. And I'm going to add as much as I can at 10 grams at a time until I can dissolve no more. I add a total of 30 grams into my beaker. 9.46 did not dissolve. So if I take the difference between those two, I am left with 20.54 grams that dissolved. Then I can reset the simulation to 20 degrees and add it until it doesn't dissolve, but we actually already did this. So I can just take this from a few slides beforehand because I already know that it's 30.65. And then I reset it. Now set at 30 degrees Celsius and potassium nitrate. Again, I'm going to add about 10 grams of potassium nitrate at a time. I get to 50 grams total. 5.56 grams did not dissolve. So the difference between those two amounts is 4.44 grams. And you continue that process. You should have gotten similar answers to mine. And next, we need to plot our data. So I gave you a little circle here on your presentation. You are more than welcome to go up to shapes and put in a different shape if you'd like. I'm going to click on it, hit Control C and then Control V to copy and paste it. And then I want to plot these data points. So at 10 degrees, I can dissolve 20.5 grams. So 10 degrees, 20 grams, right about on that line. I'm going to hit Control V, paste another copy of that dot. At 20 degrees, I can dissolve 30 grams, well, 30.65. So I'm going to try and put it about halfway between the 20 and the 40. Google Slides won't let me get too exact because it wants to format it, but I'm doing the best I can. Then at 30 degrees, 44.44. So here I am at 30. And then plot the rest of your dots. Once you've plotted all your dots, it should look similar to this. And now on our next slide, we wanted to make guesses. We wanted to make predictions. According to this graph, we want to extrapolate what we think the solubility would be at 5 degrees and at 95 degrees. I had quite a few students make predictions that about 15 grams might dissolve, maybe 10 grams might dissolve at 5 degrees. I think I had one person guess 20 grams. And then at 95 degrees, I go all the way up. How high do I think it's going to intersect? I had one student say 230, another say 240. Once we had our predictions, we actually plugged this into the gizmo. At 5 degrees Celsius, I saw how much I could dissolve. When I subtracted what I put in with what was left over, I found that our 5 degrees Celsius actual solubility was 16.86 grams. Then I plugged in at 95 degrees, subtracted what I added to what was left over, and I found my 95 degree solubility was 223.78 grams. Then it wanted us to think and explain. So potassium nitrate absorbs a large amount of heat energy from water as it dissolves. How does this explain the solubility curve you graphed for potassium nitrate? Now, I do not love their phrasing here. To say that it absorbs heat energy is correct, but it's kind of hard for us to answer this question with it phrased like that. I prefer to say it requires a large amount of heat energy. So if potassium nitrate requires a large amount of energy in order to dissolve, it needs two things to dissolve. It needs heat and it needs water. As I changed the temperature of the water, I wasn't changing the amount of water, only the heat. So there was more heat available to help my potassium nitrate to dissolve. So as the heat in the water or as the temperature increases, it can dissolve more and more potassium nitrate because it has more and more energy to pull from. So finishing those gizmos is your homework between now and your Thursday or Friday class. You need to finish what we did not finish of the solubility and temperature gizmo in class, and then proceed to the water cycle. On Friday or Thursday, we're going to be taking those solubility and those water cycle notes that are in that Google Slides document. Another thing is that your second attempt has been unlocked for the solutions, sinkhole, and rock cycle checkpoint. So if you did not get an A on your first try around, please retake that. If you still have questions, I am available during the student support and activity period on Friday. Okay, guys. Well, I'll see you again soon. As long as you make good choices and stay safe.